Science with Folly.
Kia ora. Welcome to Science with Folly. Today we're going to be learning about metals. Now metals are the elements that you'll find on the left-hand side of the periodic table. And metals form cations by losing valence electrons. And metals share similar properties. They're ductile, malleable, lustrous, insoluble, conduct heat and electricity, and most of them have a high melting point and most of them are hard. The key thing we have to learn about today is how the structure and bonding of metals affects their properties. So, metallic substances are composed of positively charged metal nuclei held in a 3D lattice, you've heard that word before, surrounded by a sea of delocalized, free-to-move electrons. Some new words there, but try and learn what they mean. So if we look at a little diagram here, all these little round circles with pluses symbolize the metal nuclei in this metal substance. And all these little negative signs represent the electrons that are moving all around the metal nuclei, and this is basically the structure of a metal. Obviously it's in 3 dimensions, this is in 2 dimensions. The key thing is that metallic bonding is a strong, non-directional electrostatic attraction between the metal nuclei and the sea of delocalized electrons that are surrounding them. So what you have to be able to do is you have to be able to describe the metal properties and relate them to the structure and bonding of metals. So firstly, metals can conduct heat and electricity. They're really good at that, and that is because they have free to move electrons within the 3D lattice. They are malleable and ductile. Malleable means they can be shaped with force, and ductile means they can be stretched into wires, and this is because the bonding is non-directional. When a force is applied to the lattice, the metal nuclei can move around, but they're still attracted in all directions to the sea of electrons. Thirdly, metals are insoluble, and the reason why is because strong metallic bonding is unable to be overcome by the attractive forces between the solvent and the metal particles. Remember, look back at the video about ionic substances and see how ionic substances can dissolve in solvents. The metal bond is too strong for the substance to be pulled apart. Fourthly, most metals are hard. Remember, that means they resist deformation, and that's yet again due to strong metallic bonds. And lastly, most metals have a high melting point. Yet again, it's because of the strong metallic bonds, and a lot of heat energy is needed to overcome the force of attraction between the metal nuclei and the sea of electrons. Obviously, not all metals are hard and have a high melting point, but most are. Some that aren't, you can think of mercury, that's liquid at room temperature, lead, you can just bend that with your hands, but most are pretty hard and have a high melting point. So there you go, metals. If you understand their structure and bonding and relate that structure and bonding to their properties, you're going to do really well. Ka kite anō. See you soon.
Science with Folly. Science with Folly.